So welcome everybody to the virtual market design seminar. We are very happy to have Michael Ostrovsky from Stanford GSB as today's speaker, the first speaker in the new term. And he will present his work on auctions for positions on choice screens. Thank you, Michael, for being here today. So let me quickly remind you of the procedures of the seminar. If you have a question, please raise your virtual hand or write your question down in the chat. And then we will ask Michael to make some breaks to leave room for questions. And then in the next break, you can post your question to Michael. There will be some breaks during the talk and also at the end to answer your questions. Now let me hand over to you, Michael. We very much look forward to your talk, and the floor is yours.
All right. Thank you very much for inviting me, and thanks for coming to this talk. It's very good to see some familiar names and also a whole bunch of new names that I haven't seen. And feel free to jump in with questions at any time. I'm happy to make it as interactive as we can online. So the title of my presentation is Choice Screen Auctions, and I'm going to talk about indeed an attempt. At the end of the talk, it will be clear why I'm calling this an attempt. A bit of a cautionary tale to use tools of market design in a regulatory framework, right? So normally we think about market design as, you have a market to design, right? You have some people on one side, on the other, and you try to facilitate their transactions. Here, the impetus for market design came from a different place. It came from sort of antitrust, IO, regulation, etc. So this makes it kind of really interesting novel setting. So let me tell you what this setting is. So the setting to which choice screen auctions apply is a very canonical, very typical regulatory concern / issue, and is becoming more and more common in the modern world as the situation starts occurring in different places. If you think about largest tech companies, most of them have something that looks like this picture on the screen, which is the following. There is a product A, that's competing with product B, and they all have their pluses, their minuses, their advantages, their disadvantages. But one salient feature is that product A is offered by platform A. And of course, platform A can intentional or unintentional or purely technologically give advantage to product A, and that makes it harder for product B to compete, even if they have some advantages of their own. And when you have a situation like that, and again, you can probably imagine dozens of cases, right? If you pick up, an Apple iPhone and you look at the apps on Apple, a whole bunch of them are made by Apple. And then the natural question is, well, if there is a competitor product B made by someone else, what do you do? Is it okay that it's made by Apple? It's not. And of course, there is a long tradition in IO and antitrust economics of how to deal with situations like that. But it turns out that most solutions are quite heavy-handed, right? So they have the flavor of, well, we should not allow platform A to enter into this product market, and compete at all, right? That's, you can see that's heavy-handed, right? Because there may be some natural advantages for the platform to make a product. Or we can have even, in the paper, I give some examples, proposals from regulators as dramatic as, let's take company A and break it into two separate companies. One will be making the platform, one will be making the product. Again, super heavy-handed. And this is where, the idea of choice screens and the idea of choice screen auctions comes in. So the idea of choice screens, without the auction part, goes back about 20 years. It was initially proposed by Microsoft in 1999 as a potential remedy in the Windows Internet Explorer tie-in case, where US regulators, sued Microsoft for bundling Internet Explorer with Windows and presumably, allegedly driving Netscape out of business. And so what Microsoft proposed, and it was not adopted at the time, is, let's do the following. Whenever a user, installs a new version of Windows or starts a computer for the first time, we're going to display a choice screen And on that choice screen, Internet Explorer is going to be one of the options, but we will also offer several other options. And then users can choose which browser they prefer. And you see how that, substantially lessens, doesn't necessarily eliminate potential tying between two products, but, really puts other browsers on a much more equal footing. And this proposal, even though it was not adopted at the time in the United States, was adopted in Europe from 2010 to 2014. There was an agreement between Microsoft and the European Commission. So for 5 years, Microsoft was in fact showing this choice screen. And by the end of the period, by 2014, it was kind of a moot issue because by then Internet Explorer was no longer dominant. So they stopped showing it. And just to give you a sense of magnitudes, this choice screen was accidentally removed by Microsoft for a period of about a year that affected 15 million users, and Microsoft admitted their error and paid a fine of more than €500 million. So even though it was for a relatively short period of time for just one version, but this is serious stuff. And this is what that choice screen on Windows looked like. You can see that Internet Explorer is one of them, and there are several other options. All right, fast forward a few years, and the same exact situation arose with a different operating system and a different product, and that is, well, partly different product, and that the operating system was the Google's Android platform, and the European Commission sued Google and eventually won, although I think this is now being appealed. The ruling that Google was illegally tying its Chrome browser and Google search app and the default search engine on the Android platform, and Google paid the fine that they imposed on Google was $5 billion, 4.3 billion euros. And as part of the subsequent settlement, again, Google agreed to display choice screens for alternative search engines and browsers to Android in Europe, for Android users in Europe, starting in 2019. And this is what this choice screen would look like, right? Of course, it's a different form factor. It's not a desktop, it's a phone. So the dimensions of the choice screen are different. It's more vertical. And the announcement was made in 2019. And the new thing, the substantively new thing, and the topic of my paper, it was that the right to be shown on the choice screen was allocated by auction, right? So Google said, look, we need to decide who to show on the screen. And the decision they made was to auction off those slots, and the auctions would be conducted quarterly. So once a quarter, they would run a new auction for the right to be shown on the screen, separate in each country. There are 31 countries that are covered by this agreement, and later in the talk I'll show you what those countries are. All the usual suspects in Europe, and so there would be 31 auctions every quarter for the right to be shown on the screen in the next 3 months. And as Google said, the auction revenues would help us to continue to invest in developing and maintaining the Android platform, right? So Android is open source, it's free. So Google said, look, this will allow us to monetize it. All right. So then the question, of course, is how does this auction work? And this is going to be the crux of the matter. And let me tell you how the auctions worked. And instead of saying it in my own words, I just took 2 screenshots from Google's own website and pasted them here because they explain it really, really well. They did a good job explaining it. So first, why does Google use an auction to determine the search providers that appear in the choice screen? And the answer totally reasonable. An auction is a fair and objective method to determine which search providers are included in the choice screen. It allows search providers to decide. And here I'm going to slow down because this is where things get important. It looks like a minor subtle point, but it turns out to be first order. So, in the FAQ section, they say, it allows search providers to decide what value they place on appearing in the choice screen and to bid accordingly, right? So Google said, look, you decide how much you value being shown and bid accordingly. Okay, but now let's jump into the actual details of how this auction works. So Google will use a fourth price auction to select the other general search providers that appear in the choice screen. You'll see in a moment why fourth price makes a lot of sense. The reason is they're going to allow 4 search engines to be shown. One of them is Google. So the other 3 are going to be the winners of the auction. So fourth price is in fact incentive compatible. So it is a very natural auction to run. So that makes perfect sense. Google will conduct auctions on a per country basis. The search providers selected in the auction will be displayed during the next 3 or 4 months, depending on the period. All right. In each country auction, search providers will state the price that they're willing to pay. And now again, I'm going to slow down because I want to highlight this and then contrast the two things. Search providers will state the price that they're willing to pay each time a user selects them from the choice screen in the given country. Okay, and I'll come back to this. The 3 highest bidders will appear in the choice screen for the country, as I said, and then the provider that's selected by the user will pay the amount of the 4th highest bid. Okay, the auction winners, including Google, will be ordered randomly in the choice screen. Okay, so that's, and then there are some additional details. So just to summarize, right, there are 3 winners, 4th price auction. The order is random, so there's no benefit in being, the top winner or the second one, and you pay the same amount and you're kind of shown in each slot with the same probability. So it all sounds reasonable, except for the 2 things that I highlighted, right? Again, at the top, they kind of say, look, you decide how much you value being shown on the screen. At the bottom, I'd say, well, you pay each time a user selects you from the choice screen, and you bid on that, right? You bid, you tell us how much you're willing to pay each time you are chosen, and when you're chosen, you pay the 4th highest bid. So let me explain to you why this is really first order and makes a huge difference. And I'm going to do it using the following example. And this is sort of the most important slide of the paper. If there is one thing you take away from the whole presentation, it's this one. So let me give you a very simple example. Suppose there are 2 search engines, search engine X and search engine Y. And suppose there's only 1 slot for sale, right? Not 3, but only 1. So of these 2 search engines, only 1 will win. Search engine X values each user at $20. Right, so whenever it's installed, the value of a user is $20, and if it is shown on the screen, 50 users will install it. All right, so this is kind of how popular it would be if it's shown. Then there is search engine Y that is different. Maybe it doesn't monetize as well, doesn't show ads as aggressively, or gives away money for good causes. All of these things are found in practice. So their value for each user is only $10. Okay, so they value each user at a lower amount. But if it was shown on the choice screen, then 5,000 users would install it. So 100 times that many. And if you think that I could have chosen different numbers, the example would still work, but the orders of magnitude are in fact similar to what you will see when I tell you about the actual search engines competing. So it's not sort of an exaggeration, this possibility that one search engine would be 100 times more popular than another. Anyway, so let's think what would happen under these 2 auction rules. So if the auction was conducted, if it was really based on who values being shown on the screen the most, well, search engine Y values each user at $10, 5,000 users would install it. So it values being shown on the screen at $50,000. Right, at $50,000. That's the value search engine Y has for being shown on the choice screen. Search engine X has a value of only $1,000 of being shown on the screen, because a lot fewer people would use it, would choose to install it. All right. So if you use the first rule that kind of was hinted at by the frequently asked questions, then search engine Y should win. But that's not what will happen here, right? Because the bidding and payments are purely for the case when the search engine is installed, then search engine X is going to bid 20, search engine Y is going to bid 10, and search engine X is going to win and pay 10 every time it is chosen, right? So this is the real problem was the design, that search engine X, even though it is a lot less popular than search engine Y, this popularity never enters into the picture. And instead, only the first bullet point matters, how much they value being chosen by a given user. And so the search engine X that a lot fewer users would install would win. All right, I'll pause here to see if there are any questions. This is a good place to ask questions because now I'm going to jump into the model and into analysis. All right, no questions? Then I'm going to continue. All right. So the model that I'm going to show you is going to be very straightforward. I try to kind of strip it down and simplify it as much as possible to make it as transparent as possible. And specifically, I'm going to proceed with the assumption that there is only one slot available. You know, the logic doesn't really change much if you have 3 slots, and it's easier to do with 1. And of course, there's 1 slot for an alternative search engine, and we have the platform's own search engine. So on the choice screen, 2 options will be shown, but only one of them is open to the alternative bidders. There are n bidders that I'm going to index by I. And what's different here relative to kind of typical auction theory that you learn, at least in the first year, in your first auction theory class, is that bidder types here are 2-dimensional, right? So bidder I has popularity that I'm going to denote by QI. That was this, 5,000 or 50,000, or 50, right? How many users or probability that the user will choose you if we show you on the choice screen. And bidder I has a more standard measure in auction theory, is how much they value each user. If you're chosen by the user, how much do you as a search engine value it, sort of lifetime value of each additional user. And for simplicity of these variables, I'm just going to assume that they're uniform on 0, 1. The logic would work for other distributions, but it's just easier to work with uniform. And that they're all independent. Now, here is another very important new feature that typically you don't see in standard auction theory. Here, the platform values each user as well, right? So if if the user doesn't choose this alternative search engine, right, the search engine that won, then it goes back and chooses Google's own search engine. And of course, the platform's value for that is higher than what others paid, because if it was lower, then we know that if Google's value for if an alternative, let's say Bing as an alternative search engine valued each user more than Google does, well, then probably there would be an agreement between Google and Microsoft where Google would allow Microsoft to run its own search engine on Google, just as what happens with Apple and Google, right? So Apple has a contract with Google where Google pays Apple for the right to be the default search engine on iOS. So, but we don't see that in other cases. So the short of that is, and the technical way I'm going to characterize this is that the platform actually has a higher value for each user than any of the bidders, right? And the reason why they're running this auction in the first place is this regulatory requirement, okay? And you will see this will come into play. This is going to be important, unsurprisingly. All right, so now let's think about our 2 auction formats. And what's interesting about both of them, right? It's a little bit unusual, right? Typically, when you study auctions, you have an incentive-compatible auction format and then not incentive-compatible. You compare their properties. Here, both of them are incentive-compatible, right? So the per appearance auction, each bidder submits a bid for how much their value is being shown on the screen, and then if it wins and it's actually shown on the screen, then it pays the second highest bid. Okay, every time it's shown. Well, in that case, your optimal bid is your value for being shown, and that is Ri times Qi, right? Your value per user times how many users, or the probability that you will be shown, that you will be chosen, conditional on being shown. All right. In the per install auction, each bidder submits a bid, and if you win and you're subsequently chosen by the user, right? I italicized it, that's where the difference is. Then you will pay the second highest bid. Again, it's incentive compatible, but now your bid is different because your popularity QI never enters into the picture. So the optimal bid is just to bid your value RI, how much you value each user. All right. Okay. All right, so let's now think through the properties of these auctions, right? So they're incentive compatible. So, optimal bidding is straightforward. I already showed it to you on the previous slide. So we just need a bit of calculus to figure out, to characterize the result. Let's first look at the per install auction. This one is actually really simple, right? Because each bidder just bids RI. The popularity of the bidders never enters into the picture, right? It's just not relevant for anything here, except, of course, for how often that will be chosen. And therefore, the expected popularity of the winner is just 1/2, right? It's the unconditional expected popularity of any given bidder, right? So the winner is as likely to be high popularity as low popularity. So on average, because we have a uniform distribution from 0 to 1, the expected popularity of the winner in the per install auction is 1/2. And now let's think about the expected payoff of the platform. Okay, where does this expression, 1/6 plus 1/2 pi? Remember that pi, it's not the 3.14. Pi is the payoff of the platform from having its search engine chosen. And so half the time in expectation, the user doesn't choose the alternative search engine, the winner, it chooses the platform. And in that case, this platform makes half of pi. And then when in the other half of the case, when the alternative search engine is chosen, the platform gets the second highest bid, right? We have a uniform distribution from 0 to 1. The expected value of the second highest bid is 1/3. So the expected payoff of the platform is, in that case, is 1/6. It's the monetary payoff it gets, the monetary payment. All right. So we characterized, how popular the winner is going to be on average and the payoff of the platform in the case of per install auctions. So now let's do the same thing for the case of the per appearance auction. And here things are a little bit harder. I'm not going to take you through the entire calculations. I'll just give you a flavor of how this calculation works. Right now, the actual two-dimensionality of the types comes into play. All right. And the first fact that's useful to observe is that, if I just take a number x between 0 and 1, then the probability that opponents bid, that the opponent's value for winning the auction is less than that, right? The probability that QIRI is less than or equal than x is equal to the following integral expression, which fortunately has a nice closed form solution. Doesn't really matter what it is. It's x minus x log x. And therefore, I can take a bidder of a particular type, QR, and the probability that this bidder is going to win is, we just plug in QR instead of X. All right. So that's how likely you are to win if your popularity is Q and your value per user is R. And then we're going to integrate that a couple of times in a couple of different forms. And the reason why we need that is then to characterize various magnitudes in equilibrium. We'll say, suppose I have a bidder whose popularity is Q, all right, and types are distributed uniformly, sorry, not types, the value per user is distributed uniformly from 0 to 1, right? So I kind of take a slice of the type space, so fixed popularity, but look at all the possible values per user of that type. So then the probability of winning is I just integrate that expression from 0 to 1. And now the details of how that integration works are not very interesting. The fact is that I can then compute it. And then finally, I can integrate over different popularities Q and compute the expected popularity of the winner. Okay, and when I go through all of this calculations, what I find is that the expected popularity of the winner is equal to 11/18, which is higher than 1/2, right? And this is not surprising when the auction is per appearance and is essentially conducted based on the product of popularity and your revenue per user. The expected popularity of the winner is going to be higher, right? Because popularity is taken into account in this auction. So in particular, it's going to be higher than if you ignore that popularity in conducting the auction. Specific value 11/18, of course, is not that important. All right. So that's one takeaway, that if you did it in the per appearance way instead of in the per install one, more popular search engines would win. Now let's look at this from the point of view of the platform. Okay, and remember that from the point of view of the platform, the expected payoff from the per install auction were 1/6 plus 1/2 of pi. Okay, and I'm going to go through similar calculations to what you saw on the previous page. Again, I need to take an integral of x log x and things of that nature. It's not very hard. And so what I find is that then the expected payoff of the platform is 7/54 plus 7/18 pi. And again, the exact formula is not important. What is important is that the expected payoff of the platform in the per appearance auction is lower than that in the per install auction, right? From the point of view of the platform, per install auction is actually better. And if you pause for a second, where is this discrepancy comes in? Why is that? Well, it's very simple. The platform has a payoff of pi, which is greater than 1, every time it is not chosen. So it actually benefits from less popular search engines being shown on the screen, right? Because it's outside option. Again, typically in auction theory, you say, look, your outside option is 0. Here, that's not the case. If it's not chosen, the platform actually has a very high payoff. All right, so let me just summarize all of these numbers. That, again, the expected popularity of the winner is half in the per install auction, more than that in the per appearance one, and the ordering reverses for the expected payoff of the platform. Okay, so this was 2 bidders. Well, sometimes what happens in auctions, we say, look, 2 is small, but once the number of bidders becomes high, that fixes all problems. Well, let's think about what happens if n goes to infinity. And here I actually don't need to go through any hard calculations. It's all going to be very intuitive because my type space is just uniform distribution from 0 to 1 for both popularity and revenue per user. So it's very easy to characterize everything. So first, let's think about the per install auction and the expected popularity. And guess what? Because popularity never enters into the picture in the per install auction, the expected popularity of the winner is still 1/2, right? Whether I have 2 draws or 17 draws, because I choose based on a mathematically orthogonal characteristic, the expected popularity is still 1/2. Whereas in the per appearance auctions, once the number of bidders is large, of course, the winner and the second highest bidder are going to be bidders who have both QI and RI very close to 1. And so the much more popular search engine would be chosen with expected popularity approaching the highest possible one. Okay, so having more bidders would improve things in the per appearance auction, would not change things in the per install one from the point of view of popularity. And if you now look at the expected payoff of the platform in the per install auction, again, it doesn't change. Sorry, take it back. It does change. The second term doesn't change, right? So half the time, the platform is going to be chosen by the user, just like before. But when an alternative search engine is chosen, then because we have a large number of them, the highest one is going to be close to 1. The second one is going to be close to 1. So the revenue that the search engine makes in the per install auction is going to be 1/2, close to 1/2 when the number of bidders is large. Okay, so half the time an alternative search engine wins, payoff of the search engine is 1, so that's 1/2, and half the time the platform ends up being chosen, and that's where 1/2 of pi comes in. Okay, now let's think about the per appearance auction. Well, here it is very simple because we're going to have winners with very high popularity and very high R. All of those are close to 1. So the default search engine, the platform, will never be chosen. You always get an alternative search engine chosen, and the platform gets a payoff of 1. 1 times 1 is 1, so that's what they get. But that's still worse for the platform than having its search engine chosen half the time and get half of pi, and the other half the time get 1. Okay, so even as the number of bidders goes to infinity, actually the dichotomy gets even worse. The difference between the expected popularity of the winner in the two formats gets wider, but the platform still prefers the per install auction. Questions, comments? All right, no questions, no comments. Let's keep going. So this analysis took this RI and QI as static, right? You're sort of born with how popular your search engine is and how much money you make from it. But of course, in practice, this trade-off is endogenous, right? So as a search engine, you can choose, how many ads to show, how intrusive those ads are, what you do with the revenues, right? So there are some search engines, I'll give you an example, if they just donate some part of the proceeds to good causes, right? Presumably that makes them more popular, but lowers how much money they make from each user. So the extension I'm going to look at is where QI and RI are endogenous, right? So there is a trade-off, as a search engine, you can become more popular and but monetize less well, and vice versa. Okay, I mean, it's just like you can think about standard, pricing, right? I can raise the price, then fewer people will buy me, but I make more per customer. Same exact trade-off, except that here it's happening in a competitive situation. All right, so there is one slot, there are n bidders, and these bidders are indexed by I. And what's different now is that bidder I just has some technological type, TI. And again, for simplicity, I'm going to assume it's drawn from the uniform distribution on 0 to 1. And this technological type just is how good you are, right? What's your possibility frontier in the space between QI and RI? And for simplicity, I'm going to assume that the trade-off just takes a very simple linear form, okay? And this is actually not as restrictive as you may think, because if you think about, a point close to the optimum, it's always approximately linear, right? As we know from calculus. And the fact that the slope is 1, or -1 in this case, is totally okay, because I can just rescale things and then, slope will be -1. Anyway, so prior to the auction, I know my technological type. And now I say, well, how popular do I want to be versus how much do I want to monetize? So I'm going to pick my popularity QI, which has to be less than TI, and then the remainder, TI minus QI, is going to be how much money I make from each user who chooses my search engine. Okay, and from that point on, everything else is the same as before. So in particular, in the per appearance auction, I submit my bid that's the product of RI and QI, and the per install auction, I submit my bid that's equal to RI, right? So once I chose my QI and the corresponding RI, everything else is the same as before, but of course there is this extra step. How do I choose those? So let's analyze what will happen in this auction, under these two formats, when search engines can in fact choose their popularity versus the revenue. So let's first start here with the per appearance auction, because it turns out to be simpler. So, consider an auction, there are n bidders, and suppose my type is TI, okay, some number. Fix other bidders' strategies, okay? I don't know their types, but I know their strategies. And let G of X denote the distribution of first order statistics, right? The expected first order statistic of the highest bidder. And let PX denote the expected payment that bidder I would make conditional on winning the auction if he submitted bid X. All right. So I'm this bidder, and I have two. So my type is TI, right? And I have two decisions to make: what popularity to choose, and of course it will determine how much money I make from each user I get. And then, given that, what my bid is. Okay. Even though I know it's incentive compatible, I know what my optimal bid is, but it's convenient to pretend for just a second that I don't know that. Okay. So what is my expected payoff as a function from these two choices? Well, the first one, I have this distribution G of X. It's just a probability that I'm going to win relative to that distribution. So that's just G of my bid. Okay, that's really simple. And then every time I win, how much am I going to make? Well, I'm going to make QI times TI minus QI. That's my revenue per user times how likely the user is to choose me, minus my expected payment. And if you stare at this expression, right, you notice that BI and QI can get separated in two different parts of it. And specifically, once I know what my optimal B is, then my optimal choice of QI doesn't depend on G of B of P of B. Those are entered additively and multiplicatively. Okay, so the only thing that matters is this term. And of course, it's really easy to maximize this term, just like, the optimal price, if you have a linear demand, distributed from 0 to 1 is 1/2. Here, you say the optimal thing to do is to allocate half of your type to the popularity and the other half to revenue per user. So your optimal choice of popularity is just TI over 2. Okay, it doesn't depend on anything else. It doesn't depend on distributions, on G, on P, on anything. Okay, so, and in particular, it doesn't depend on the number of bidders and what they do. It's actually a standard feature of VCG. So in VCG, we know that there is a similar property that when you can invest, you're actually going to invest optimally under VCG pairs, if you can invest in things like quality. And the per appearance auction, if you pause for a moment, is in fact VCG, right? So that's why it kind of inherits this quality. Now let's think about the per install auction, and here things are a little bit more difficult. And again, I'm not going to take you through all of the calculations, but I give you a flavor of what they feel like and what they look like. So take this per install auction and consider a symmetric equilibrium of this per install auction with n bidders. And suppose you have these equilibrium strategies just like before, given by Q of T and B of T, right? So that's same as on the previous slide. And now here is the only subtle point in the analysis where you need to be careful. So take a bidder of some type TI and take a small number delta Q such that TI plus delta Q is still in 0, 1, right? So we're going to think about a small perturbation. It's going to be essentially a first order condition for the choice of the quality. And so let pi of delta Q and TI denote the expected payoff of the bidder whose type is TI, but it chooses the popularity that's supposed to be chosen by a slightly different type TI plus delta Q, but still bids in the same way as he's supposed to, still bids B of TI. Okay, so we're perturbing our choice of popularity a little bit without changing the bid. So what is my expected payoff in that case? Well, so first of all, because I'm bidding as my type is supposed to bid, it's just the probability that I'm the highest type of the n bidders. So that's easy. So then The next thing is the probability that I will in fact be chosen. It's this popularity of this type that I pretend to be. And finally, every time I'm chosen, I'm paying, I make the revenue that I make per user, right? That's just RI, given my choices, minus some complicated expression of what is the expected bid of the second highest bidder, conditional on me winning. Okay? And one thing to note is just mathematically, if I forget for a moment about all kinds of economics, if you go back to the previous slide, right, we had this term QI times TI minus QI, which just kind of completely fell out of the entire expression, right? Like all the payments and probabilities of winning did not affect my incentives regardless of the choice of QI. Here, that is not the case. QI goes here, but then when I pretend to be a higher type, that also means that I'm going to pay more when I win. And if you take the first order condition with respect to delta Q, what you find is that the optimal popularity is going to be TI minus this expected payment, conditional on me winning, divided by 2. And so you can immediately, without making any additional calculations, see that the search engine has an incentive to choose a lower popularity and a higher revenue per user, right? Because this expectation is going to be a positive number. How much lower, we need to do some more math, which I'm going to skip. I'll just flash the slides in front of you. It's not that complicated, but it's not that insightful either. And if you go through all of these calculations and expand this, expected value and do more calculus, what you end up with, in fact, is a very simple differential equation and a very simple solution that in the per install auction, the popularity that the search engine will choose is TI over n plus 1, where n is the number of bidders, right? So if he's the only bidder, if I know that I'm the only bidder, I'm going to choose, my my popularity in the same fashion as under per appearance, because I'm going to win anyway. I'm going to choose QI equals to TI over 2. But once n goes higher than that, my popularity becomes worse and worse. Whereas again, in the per appearance auction, the number of bidders doesn't affect what I choose in terms of my popularity. And so to summarize the results, in the per appearance auction, each bidder sets popularity TI over 2 and revenue TI over 2. In the per install auction, it's very, very different. You put a lot more weight on revenues. And unsurprisingly, the expected popularity is strictly higher in the per appearance auction, and the expected payoff of the platform, which you can compute, is strictly lower in the per appearance auction than in per install. And the last thing I want to say about the theoretical results and move on to data is this really kind of troubling fact, troubling property, that if you think about what will happen as the number of bidders goes to infinity, right, a standard comparative static exercise, well, in the per appearance auction, things will be nice because everyone still chooses popularity as TI over 2, but the quality of the winner will become very high. In the per install auction, competition actually drives these bidders to set popularity as low as possible and put all the weight on monetization, right? So the more bidders you have, the less likely is it that the alternative search engine will in fact be chosen. And almost with probability 1, the default search engine gets chosen instead. All right. Okay, so let me jump to, I have 15 minutes left. Let me jump to the actual data to see how this stuff manifests itself in practice. And so I have data from 1 year worth of these auctions. So 4 batches for all of the auctions that were conducted in 2020. And in each period, there were 31 independent auctions, 1 per country. Auctions, as I already mentioned, of course, were done on a per install basis. With top 3 winning, and all of the outcomes, are publicly disclosed by Google. They, publish them. They don't publish the bids, but they do publish, who won in which countries. And here is a full summary of these outcomes. So let me walk you through this table to allow you to read it. So first of all, I took all the countries, sorted them by population from largest to smallest. That's on the vertical axis. And the total population of the countries affected by this is about 500 million people. And now on the horizontal axis, I put all the search engines that won at least once, that I see at least once in the data. And in each cell, what I put is which of there are 4 auctions for each country that were conducted, right, 4 different time periods. So in each cell, I put in which periods in that country did that search engine win. So for example, if you look at DuckDuckGo and Germany, so DuckDuckGo won in Germany in periods 1 and 2, but lost in periods 3 and 4, or maybe didn't participate. I don't know, but they did not win. Okay. And so then for each search engine, I can say, well, on average, across these 4 time periods, was the total population that they won. And that's the number I put at the bottom. I could alternatively do it by just counting the number they won. You get very similar takeaways and answers. Anyway, so after I do that, then I sort the search engines from left to right by the population that they won. So info.com, that I doubt anyone here has heard of before this talk, won every single auction in every single country, every single period. And so the population that they won, the average population that they won, is the same as the population of the affected countries. It's 519 million.4. Privacy Wall was the next largest bidder. They won an average population of 373 million. Then you have a couple of names that are familiar, DuckDuckGo and Bing. And then you keep going. And the last one is the search engine Ecosia, which I'll actually have a little bit more to say about in a moment. And they won in only 1 country in 2 out of 4 periods. So it's a small country. I think they won in Slovenia. So their average population is 1.0. Okay. So now you can look at this and say, well, okay, info.com and Privacy Wall won. You haven't heard of them, but maybe they're this amazing search engines. You just don't understand how fantastic they are and how popular they are. And so then what I did, I said, look, I can go to Google Play Store and just look at what these things are and how, whether they're actually popular or not. One special feature of how this was implemented is that if you chose one of these 10 as a default search engine as a user, then Google would automatically install, as part of the whole process, they would install their dedicated search app on your phone. And so that would count as a download from Google Play Store. So while I can't know exactly how many users chose different options, chose different options and actually chose to install them, I have upper bounds, right? So Play Store gives me upper bounds, and it also gives me things like how many reviews these guys have, like how many users actually reviewed them, and what their ratings are on the 5-point scale. And so when you add this data to how much they won, then I think things become very, very clear. So the 2 top search engines, info.com and Privacy Wall, even though they won this massive number of auctions, the total number of installs, and again, we're talking about the population of 500 million people over a course of a year, the total number of installs was in the order of 50,000 for one and 100,000 for the other, which is basically, for all practical purposes, essentially 0, right? If you compare it to DuckDuckGo or Bing, those have 10 million installs or more. So literally multiple orders of magnitude. And if you look at Ecosia, which I said I will already, I said I'll mention, they actually also have a large number of installs. So Ecosia is the search engine that some of you may have heard of and some of them may not, because they focus on some parts of the world, specifically on Europe. Their model is they take some of their revenues from ads and donate them to plant trees worldwide. Okay, so it's a very direct trade-off between monetization and popularity. So they are quite popular, but of course they don't monetize nearly as well as they would if they just kept all the money. And then you can also look at things like how much do users like this search engine? Maybe they're just undiscovered gems, and that also doesn't seem to be the case. The ratings that info.com and Privacy Wall have are 4.1. which is much lower than, DuckDuckGo at 4.8, Ecosia at 4.6, and some of the others. Okay. And again, you can look at the number of reviews. Are users enthusiastic? Maybe they have a small but dedicated fan base, and that's really not the case, right? We're talking tens, or one, privacy wall, we have 200 something reviews compared to a million with DuckDuckGo, right? And if you ask yourself, well, how can they possibly win this auctions? Well, my paper explains that, right? Because you pay only when you're chosen. So for info.com, it doesn't actually matter. I mean, they would prefer to have more installs, but they're still willing to win because they only pay when they are in fact chosen. All right, so this is this is sort of evidence for the first part of the paper. Now, in terms of incentives for the trade-off between quality and between popularity and revenues, I don't have enough data, and it's only been one year, so I don't have any direct kind of empirical evidence, but I do have quotes from the search engine that they fully understand these incentives. So DuckDuckGo, which, as I already said, was the most highly rated search engine, said, look, despite us being robustly profitable for a number of years, we've been priced out of this auction, because we choose not to maximize our profits by exploiting our users. In practical terms, this means our commitment to privacy and a cleaner search experience translates into less money per search. Right? This means we must bid less relative to other profit maximizing companies, right? So if the payment was not per user or per search, but rather per appearance, because they're so popular, they might easily win. Well, who knows? We don't know the counterfactual, but at least they would have a shot. But when it's done on a per user basis and monetization on a per user basis, they can't compete. And then Ecosia says a similar thing, not-for-profit search engine. Taking part in this auction would force us to spend our income on an unnecessary bidding war. We'd rather use it to plant trees on the planet. All right, so let me conclude with a couple of slides. So conclusion. So this is a new regulatory tool. So even though I pointed out these issues with the design, I actually want to give kudos to Google and the European Commission for trying new solutions, right? So it's sort of, the world is complicated. These are complicated issues. Technology changes very fast. So we should be trying new things. We should be trying new approaches. And, they deserve quite a bit of credit, even for trying to do this new approach. It's potentially applicable in lots of other important settings, right? So you pick your favorite tech company, right, with market cap more than $1 trillion, and you will probably immediately think of cases where they serve as a platform, right? That's how they became those $1 trillion companies, and they have their own products on top of those platforms, and they have competing products on top of those same platforms. So in principle, this tool can be applied in many other cases. I'm not saying that should be used everywhere, but potentially applicable in lots of different places, but needed to be fixed, right? The first implementation where the auction was conducted on a per install basis is just not the right way to do it. And I hope I convince you both theoretically, and also when you look at the outcomes that's of this auction, that seems fairly convincing. And when I first wrote this paper, that's sort of where the paper ended. And when I was invited to give this talk, that's where the paper ended. But now it has an epilogue. And an epilogue comes from an official Google announcement earlier this summer, June 2021, where they basically said that they're going to stop auctioning the slots. So they said, look, following further feedback from the European Commission, we're now making some final changes to the choice screen, including making participation free for eligible search providers. These changes will come into effect from September of this year on Android devices. So I don't have any insider information of what made into this decision, what kind of arguments contributed to this decision, to what extent these types of considerations and my results came into play. I'm pretty sure the fact that info.com and Privacy Wall were the two biggest winners in these auctions did not help with the credibility of this auction. I actually do think it was a strong contributing factor, but of course, I don't have any ironclad proof. What we do know is that, there was an attempt to use auctions in this regulatory setting. There was I feel comfortable calling it a flaw in the design that resulted in sort of strange results with unpopular search engines winning for understandable reasons, even though this detail seems pretty minor, right? Whether you conduct the auction on a per impression basis, per appearance basis, or per install basis, but this seemingly minor detail actually turns out to have first order consequences, and quite likely sort of doomed this particular auction from the start. All right, on that I will stop. Thank you very much for coming, and I'm happy to take any questions.
It seems there are currently no questions. It
That's
would,
okay.
of course, have been quite interesting to understand the European Commission's opinion about this. What made them, but you already said that you don't know.
I think a lot of things were happening behind closed doors, but I don't know. I mean, I shared this paper with the European Commission and with various other regulators, but again, I don't know to what exactly went into the decision. But as I said,
they were aware of the arguments.
Yeah, I do think that the actual empirical results of who the winners were, and that there were these unpopular, low-quality search engines, was not helpful for this design.
Do I get a wrong impression? Is it like in Europe, it's a competition between DuckDuckGo and Bing? And those like InfoWar and privacy war are trying to kind of like easy that kind of competition between DuckDuckGo and Bing.
Well, so let me take this for one second. So I mean, in Europe, it's not just DuckDuckGo and Bing, right? It's also Cozy is, so it's pretty popular. It has 5 million downloads. Again, on the scale of Google, maybe it's not that huge, but in the scale of those two, it's comparable. There is Yandex that's very popular in Russia and Eastern Europe, could in principle expand further. There is Yahoo, right? So they did not participate in this, but they do have a search engine. They have several million installed. So there are actually quite a few options. And I mean, there is an argument that, the current format potentially makes it easier for a high quality unknown entrant to enter. But then if you're a high quality entrant, you should also be willing to participate in the per appearance auction as well, right? And, that will give you some more credibility. But yeah, so in principle, there are quite, and in fact, if you go back, so it's a little bit, let me go back to my slides. If you scroll back to an early slide where Google put their own screenshot of what they thought the winners would look like, right? Who they expected to be there. It's very early in the slides. PowerPoint, of course, does things one by one. Here we go, right? So they thought that the three most likely winners would be Yahoo, DuckDuckGo, and Bing, right? So that's what they thought. All right, another question. I see there is a question in chat that says, in the theory part, is there any monotonicity result when jumping from n equal to 2 to the limit case? Good question. So I didn't show any monotonicity results like that. I just did it for n equal to and n equal to infinity, but I'm pretty sure just from the structure of the problem that you would have a monotonicity result, that the more bidders you have, the higher is going to be the expected quality of the winner in the per appearance auction, but of course not in the per install one.
Okay, it seems nobody's, or one more question?
Yeah.
I do have a question. Do you hear me?
Yes, I can hear you.
I was wondering whether you did some sort of optimal, whether you've looked into some sort of optimal mechanism design question. Like, could you think about what the optimal revenue maximizing auction from Google's point of view is, or whether you could also look at the optimal auction from the point of view of the regulator, like the auction that minimizes the probability that Google is going to end up being the chosen search engine. Is that possible? Is that tractable in your model?
Okay, so it's a fantastic question. I have an answer to part of your question and then thoughts on the other part. So in terms of the optimal from the point of view of Google, in my model, it's very, very simple. And that is just to not to run the auction, right? Because by assumption, the Google's payoff is highest from just keeping the users, which is sort of realistic. Then the optimal mechanism, like anything that never generates any winners, or anything that produces winners who no one ever chooses, no one ever installs, would be the optimal thing for Google. So that's easy, but not very interesting. The other part of your auction, of your question is much more interesting, and that is, so this is sort of a market design paper. I compare it to market design, but on some level, it's not a mechanism design paper, because I don't start with a well-defined objective function for either the regulator or the auctioneer. Right? I don't have, typical mechanism design papers. Okay, here the objective is the efficient auction, or as you said, minimize something or maximize something. And I actually do think that there is a really wide open area here to think about the mechanism design question, because, as I said, I think the number of potential applications of those is large, and it's important to think. I don't think that the objective of the regulator should be to minimize Google's market share. That just doesn't sound right, because if that market share is minimized by flooding the market with low quality search engines, that's not good either. So you will first have to think very carefully about the objective function, and once you have it, I do think it would be a really interesting question to think about what the optimal. There are actually two sets of questions. One set of questions is, if you are the regulator and you're designing the auction, how can you, or some more general mechanism here, how would you do it? And the second question, which is even harder conceptual, but maybe more realistic, is notice that this auction was actually designed by Google. Like, they talked to the European Commission, but at the end of the day, they designed the auction. It's not surprising they're in the best position to run it, to design it. So then the question becomes, if you're the regulator and you know that the platform is going to design the mechanism, right? And then when they design it, they'll take their interests into account, but you can put some limits on it, right? You can give some parameters to what the platform can do when they design their mechanism. What should those parameters be, right? That's conceptually even harder, but maybe more and maybe more realistic, because that it's like, I can't imagine there's going to be a law that says that choice screen auctions have to have this form. But it's actually possible to imagine a law that says that when something like choice screen auction is chosen, these are the parameters that it needs to satisfy. All right. Thank you. And if you have any more questions at any point, feel free to email me, contact me. I'm always happy to talk about this.
Yeah, thank you very much for this interesting talk so early in your morning. Hope you have a good day. It was a good start. And thank you, everybody, for the participation. And we hope to see you again in 2 weeks, when we have the pleasure to welcome Martin Bichler.